Good evening, students. Yesterday theory completed. Now let us do problems on Newton-Raphson method. Write down problem number 1. What is the value of 1525 whole power 0.2 to 2 decimal places option A 4.34, option B 4.36, option C 4.38, option D 4.30. This problem given in the Engineering Services Examination Prelims Paper 2018, ESC 2018. Prelims. Now you observe here 1 by 2. 1 by 2 means 2 by 10. 2 by 10 means 1 by 5. That is fifth root of a number. What is the Newton-Raphson iteration formula for fifth root of a number? Suppose you don't know that, then you can write pth root of a number. Pth root of a number is 1 by p into p minus 1 into xn plus capital N by xn power p minus 1. This is the pth root of a number, but we just need fifth root of a number. 0.2 means 2 by 10 means 1 by 5. That is fifth root of 1525. Fifth root of n. Fifth root of n is equal to 1 by 5 into. So take p is equal to 5. 5 minus 1, 4. Plus capital N by xn power p minus 1. 5 minus 1, 4. Now we need to find fifth root of 1525. That is 1525 whole to the power of 1 by 5. Whole to the power of 1 by 5 means 0.2. That is equal to 1 by 5 into 4xn plus capital N value 1525 divided by xn power 4. Listen to me. Actually, in the examination, we will be asked to solve one problem using Newton-Raphson method. But sometimes in the examination, they will not mention. Even though you are asked to, you are not mentioned to solve this problem using Newton-Raphson method, still we can solve this problem using Newton-Raphson method. Because square root of a number, cube root of a number, fourth root of a number, inverse of a number, etc., etc., can be found using Newton-Raphson method only. Moreover, regarding Newton-Raphson method, initial approximation value must be given in the statement of the problem. But in this problem, initial approximation value not given. Means x0 value must be given in the statement of the problem regarding Newton-Raphson method. But in this problem, initial approximation x0 value will not be given. But my strong suggestion, whenever the initial approximation is not given, in all such cases, please look at the options. Option A, option B, option C, option D. All options are lying between 4 and 5. All options are lying between 4 and 5. So average of 4 and 5 will be taken as initial approximation. Whenever the initial approximation is not given, then you need to observe the options. All options are lying between 4 and 5, or you may also write all options are lying between 4 and 4.5 also. All options are lying between 4 and 4.5. So average of 4 and 4.5 should be taken as the initial approximation. So the initial approximation is, you can take the average of 4 and 5, or you can take the average of 4 and 4.5 also. And tell me the value. 8.5 divided by 2. 4.25. Now the first approximation denoted by x1. So to get x1, look here, 1 minute. This is the value of xn plus 1. And look at everyone, this is the value of xn plus 1. To get x1, take n is equal to 0 here. If I take n is equal to 0 here, you will get x1. So x1 is equal to 1 by 5 into n value 0, 4x0, 1525, n value 0, x0 power 4. Substitute and then simplify. So x1 is equal to 1 by 5 into 4x0. x0 value 4.25 plus 1525 by 4.25 whole to the power of 4. Simplify this and let me know its value. Tell me its value. 4.334. 4.334. 4.334. Still you do not get any clarity, then look at the options, all of you. 4.334, your answer is, listen to me, your answer is very, very nearer to option A. So option A is the right answer. If you have a doubt, you can find one more value also, just for the sake of clarity. X2 is equal to get x2, take n is equal to 1 here. 1 plus 1, 2. X2 is equal to 1 by 5 into to get x2, take n is equal to 1. 1 plus 1, 2. X2 is equal to 1 by 5 into 4x1 plus 1525 divided by x1 power 4. Substitute x1 value 1 by 5 into 4 into x1 value 4.334 plus 1525 divided by 4.334 whole to the power of 4. Please simplify this and let me know the answer. What is the answer? 4.331. Stop. Your answer is approximately 4. Your answer is approximately 4.34. So option A is the right answer. Your answer is approximately 4.34. So option A is the right answer. Remember my strong suggestion, all of you, everyone, whenever the initial approximation is not given, look at the options. All options are lying between 4 and 5. So average of 4 and 5 means 4.5 is the initial approximation. But I have taken average of 4 and 4.5, but suggestible average of 4 and 5. Please do remember that. Similarly, note this and try yourself. For n is equal to 30 and we were given initial approximation x naught is equal to 2. The first approximation of fifth root of 30 by Newton's iteration formula is option A 1.965, option B 1.905, option C 1.975, option D 1.945. Try yourself it later. One more. I don't know the answer. Please verify yourself. What is the value of 1525? All branches problems you need to practice relevant to your syllabus. 1525, sorry, 1468, sorry, what is the cube root of? What is the cube root of? 2, 3 decimal places. Option A 11.340, option B 11.353, option C 11.365, option D 11.383. And this problem was also given Engineering Services Examination 2018 prelims paper. Listen to me. Regarding numerical methods, initial approximation value must be given. Whenever the initial approximation is not given, then please look at the options. All options are lying between 11 and 12. So average of 11 and 12 will be taken as the initial approximation. Average of 11 and 12 is 11.5. So initial approximation should be taken as 11.5 and then proceed yourself. Option C is the right answer. Try later, similar to the first problem model. Next. I don't. Newton-Raphson method is used. I think notes uploaded. If not uploaded, I'll share the notes or they will upload the notes. Newton-Raphson method is used to find the root of the equation 3x minus e power x plus sin x is equal to 0. If the initial trial value for the root is taken as 0.333, the next approximation for the root would be dash. Note answer up to 3 decimal places. Was given in the GATE Civil Engineering 2016. So the given function, let it be f of x. So f of x is equal to 3x minus e power x plus sin x. And we were given initial trial value. Initial trial value means initial approximation given to be 0.333. Find f dash of x. F dash of x is 3x derivative 3, e power x derivative e power x, sin x derivative cos x. So find the first approximation value. You are given initial approximation. You are asked to find the next approximation, means first approximation, means x1. Already yesterday we found x1 value for Newton-Raphson iteration formula. X1 formula for Newton-Raphson method is x naught minus f of x naught by f dash of x naught. What is x naught? 0.333 minus f of 0.333 by f dash of 0.333. Substitute this value, f of 0.333, that is 3 into 0.333, small e value 2.718. So that is e to the power of 0.333 plus sine of 0.333 by f dash of 0.333. Take x is equal to 0.33 here. That is 3 minus e to the power of 0.333 plus cos of simplify this and let me know the answer. Three decimal places they mentioned 0.3601. 0.3601 is the answer. Next, note this and try yourself. The first approximation to a real root of the equation x cube minus 5x square plus 6x minus 1 is equal to 0. With initial guess, x naught is equal to 1. Using Newton-Raphson method is dash. Try yourself. I am not sure about the answer. Very simple answer. Observe, I think answer is 2. Answer is 2. What is the answer? 2 will be the answer. Next, I don't use Newton Raphson method. Find the first two approximations of 1 by 26 1 by 26 with initial guess x naught is equal to 0.04. So 1 by 26, that is 1 by n. Newton-Raphson iteration formula for inverse of a number, that is 1 by n. Xn plus 1 is equal to xn minus nxn square. In place of capital N, 26 is there. Substitute n is equal to 26. So for 1 by 26, the formula will now be xn plus 1 is equal to 2xn. No, I gave yesterday, please verify 2xn. The formula is 2xn minus nxn square. Capital N means 26 xn square. Now, first approximation denoted by x1. To get x1, take n is equal to 0. That is 2x naught minus 26 x naught square. 2 into x naught value 0.04 minus 26 into 0.04 whole square. Tell me the answer. Similarly, to get the second approximation, I mean to get x2, take n is equal to 1 here. X2 is equal to 2x1 minus 26 times of x1 whole square. So 2 into what is x1 value? What is x1 value? (0.0384). So take x is equal to 0.0384 minus 26 into 0.0384 whole square. Simplify this and tell me x2 also. 0.03846. Fine. 0.03846. So almost the same answer only. Next. Write down. Consider the series xn plus 1 is equal to xn by 2 plus 9 by 8xn, where x naught is equal to 0.5, obtained from the Newton-Raphson method. Full stop. This series converges to option A 1.5, option B √2, option C 1.6, option D 1.4. GATE Civil Engineering 2007. This problem can be done in two different ways. I will let you know both methods. First of all, what is given? Xn plus 1 is equal to xn by 2 plus 9 by 8xn. Nine by 8xn. 1 by 2 is the common factor from the right side. If I take out 1 by 2, it becomes xn plus 9 by 4xn. I can also write like this. One by 2 into xn plus, take this 4 in the numerator, 9 by 4 divided by xn. Please verify the formula of square root of a number. This is the Newton-Raphson iteration formula for square root of a number 9 by 4. Square root of a number Newton-Raphson iteration formula xn plus 1 is equal to 1 by 2 into xn plus capital N by xn. In place of capital N, we have 9 by 4. Root of 9 by 4, that is 3 by 2. 1.5. Another method we can do like this also. Tell me, when do we stop the iteration process? Remember everyone, the difference between one approximation and its previous approximation. The difference between one approximation, let it be n plus 1th approximation. The difference between one approximation and its previous approximation is less than or equal to epsilon. Then we can stop the iteration process. One approximation is n plus 1th approximation. Previous approximation is nth approximation. Do you know this formula? Mod x less than or equal to a. Formula minus a less than or equal to x less than or equal to a. This is mod x less than or equal to epsilon. So this is minus epsilon less than or equal to xn plus 1 minus xn less than or equal to epsilon. Epsilon means what? Any number very nearer to 0. Epsilon is any number very nearer to 0. So xn plus 1 minus xn value should lie between minus 0.0001 and plus 0.0001. Any number that lies between minus 0.0001 and plus 0.0001 is almost 0 only, is approximately 0. That's why xn plus 1 minus xn value 0. So xn plus 1 is equal to xn. Xn plus 1 is equal to xn. So in the original iteration formula, what is the original function we were given? Xn plus 1 is equal to 1 by 2 into xn plus 9 by 8 xn. 9 by 8 xn. Now this method, whenever the question is the particular method that is convergent to, the particular method is convergent to which of the following? In all such cases, simply substitute xn plus 1 is equal to xn. That's it. We will get the answer. Xn plus 1 is equal to xn. Then we get the answer. I simply substitute xn plus 1 is equal to xn. Then it is xn is equal to 1 by 2 into, sorry, I'll modify. The given is xn by 2, sorry. So xn by 2, here xn by 2 will go left side, then it becomes xn. This is xn is equal to xn by 2 plus 9 by 8 xn. Xn by 2 will go left side, xn minus xn by 2. Then it is xn by 2 is equal to 9 by 8 xn. 2 ones, 2 fours. So by cross multiplication, xn will go left side numerator. So xn square is equal to 9 by 4. So xn is equal to plus or minus root of 9 by 4. Minus symbol is not there because among 4 options, all options are with plus symbol only. That's why plus 3 by 2, that is 1 by 5. Next. The Newton-Raphson iteration xn plus 1 is equal to 2xn cube plus 1 by 3xn square plus 1 can be used to solve the equation. Option A, option B, option C, option D. Try yourself. This is also 100% similar to the previous problem model. Simply substitute xn plus 1 is equal to xn. Substitute xn plus 1 is equal to xn and simplify. Definitely you get option A. To solve all these types of problems, simply substitute xn plus 1 is equal to xn. We will go to the next model. Topic number 2. Single and multi-step methods. Single and multi-step methods for first order ordinary differential equations. What is the general form of first order and first degree differential equation? Write down. The general form of first order and differential equation with initial condition is, remember, dy by dx is equal to f of xy. This is the general form of first order differential equation. Initial condition is y of x naught is equal to y naught. Means y value at x naught should be y naught. Y value at x naught should be y naught. Now, what do you mean by first order differential equation? Any first order differential equation solution cannot be evaluated. All the type of first order differential equations can be evaluated with the help of numerical methods. To find the solution of any first order differential equation regarding numerical methods, first of all, we need to assume that the solution of the differential equation. Everyone should remember, solution of the first order differential equation or second order differential equation or any differential equation will represent one curve. Solution of the differential equation is one curve. After finding the differential equation, you will get one equation. For that equation, we are writing the curve. Means this is the solution of the differential equation. In numerical methods, to find the solution of any first order differential equation, we need to assume that the solution of the differential equation must be split up into equal number of subintervals. The solution of the differential equation must be split up into equal number of subintervals. The length of each subinterval is same. This curve is the solution of the differential equation. That curve that was split up into equal lengths of subintervals. Now, right. The solution of the differential equation should be divided into equal number of subintervals. Remember, the length of each subinterval is called step size. Step size or step length. Each subinterval length is called step size or step length. And is denoted by h. Every subinterval length is called step size. Now, what is the length of the first subinterval? The subinterval length is x1 minus x0. every subinterval length is same and is denoted by h. So from this, x1 is equal to x0 plus h. Second subinterval length is x2 minus x1. Let it be h. So from this, x2 is equal to x1 plus h. So x2 is equal to here x1. X1 value already found here, x0 plus h. Plus h. So that is x0 plus 2h. Similarly, guess x1 is equal to x0 plus 1h. x2 is equal to x0 plus 2h. x3 is equal to x0 plus 3h. x4 is equal to x0 plus 4h. xn is equal to xn plus x0 plus nh. So from this, nh is equal to x0, xn minus x0. So from this, h is equal to xn minus x0 by n. Remember everyone, h means length of the subinterval. Length of each subinterval is equal to end point of the interval minus initial point of the interval divided by total number of subintervals. End point of the interval minus initial point of the interval divided by total number of subintervals. That is called length of each subinterval and is denoted by step size. And is denoted by h called as step size. Now there are several methods to find the solution of first order and first degree differential equations. Yes, there are several methods to find the solution of first order and first degree differential equations. The first model is Taylor series method. So everyone should remember, whenever you are unable to find the solution of any differential equation, I mean first order differential equation only, its a solution can also be determined with the help of numerical methods. One of such method is Taylor series method, Euler's method, Runge-Kutta methods. We have different methods are there. Write down. Given dy by dx is equal to f of x comma y. This is the general form of first order differential equation. With initial condition y value at x naught is equal to y naught. Y value at x naught is equal to y naught. Write down the Taylor series expansion about the point x is equal to x naught is y of x is equal to y of x naught plus x minus x naught into y dash of x naught x minus x naught whole square by 2 factorial into y double dash of x naught plus x minus x naught whole cube by 3 factorial into y triple dash of x naught plus 1. Any function which is a differentiable at x is equal to x naught, that function can be expanded as a Taylor series in powers of x minus x naught. Now, at x is equal to x1, then y of x1 is equal to, I'm finding this Taylor series at x is equal to x1. Y of x1 is equal to y of x naught plus x1 minus x naught into y dash of x naught plus x1 minus x naught whole square by 2 factorial into y double dash of x naught plus x1 minus x naught whole cube by 3 factorial into y triple dash of x naught, so on. You have already written earlier x1 minus x naught value h. Look there. X1 minus x naught is equal to h. In place of x1 minus x naught, I will write h. So y value at x1 is equal to y of x naught plus x1 minus x naught is h. H into y dash of x naught plus h square by 2 factorial into y double dash of x naught y triple dash of x naught plus 1. Now let us see the definition truncation error. So what do you mean by truncation error? Tell me which part you are feeling complicated. Till now, we did any doubts regarding this part? Any doubts regarding this part? You can ask if you have doubts or if you are unable to understand. Because some students, they are mentioning if you have a doubt, this is Taylor series. Series means sum of finite number of terms or infinite number of terms. Truncation error. I will teach you. Everyone should be very careful regarding truncation error. Actually, there are several methods. We are at actually what is the topic name? You should be careful. Bisection method, regular falsy method, secant method, Newton-Raphson method. All these 4 methods should be used. to find the solutions of nonlinear equations. There are two types of nonlinear equations. Two types of nonlinear equations. Algebraic equation degree greater than 1 or transcendental equation like log x minus cos x is equal to 0. Transcendental equation means a trigonometric, hyperbolic, logarithmic, exponential. So to find the roots of e power x minus cos x is equal to 0 or x cube minus x minus 1 is equal to 0, we can use previous four methods: bisection, regular falsies, secant, and Newton-Raphson methods. And when do we use the single and multi-step methods of ordinary differential equations? Suppose you are unable to find the solution of any first order differential equation. All those first order differential equations can be evaluated with the help of numerical methods. There are several numerical methods to find the solution of first order differential equation. Among all those, the first method is a Taylor series method. With the help of Taylor series also, we are able to find the solution of a first order differential equation in this format. Any first order differential equation in this form, and you are unable to find its solution. For example, look here, dy by dx is equal to sine of x square plus 2 plus sine of x square plus 2 plus y. You cannot find the solution of this differential equation directly. Now its a now its a solution can be determined using Taylor series or Euler's method or modified Euler's method, etc., etc., etc. So before going to discuss about that, from Taylor series, we come across a definition of truncation error. Everyone should be careful. What is truncation error? Truncation error means the error arises. Don't worry, I will explain with an example also. The error arises when an infinite series is truncated. Truncated means cut. Truncated means cut. Truncated. When an infinite series is truncated by a polynomial, then little bit error will be generated. That error is called truncation error. Don't worry, I will explain this truncation error with an example. First, you leave 4 lines gap, write the example. There we write the definition. I will write the definition here. Take an example. Sin x is equal to x minus x cube by, this is sin x expansion, plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus 1. Now, actually, truncation error means, suppose I want to find sin x value at x is equal to 0.5. If you take x is equal to 0.5 in the left side, you will get sin of 0.5. Tell me the value of sin of 0.5 up to 10 decimal places in terms of radians. Can anybody tell me sin of 0.5 up to 10 decimal places in terms of radians? Sin of 0.5 up to 10 decimal places in terms of radians. What is the value? 0.4794. Different answers you are giving. Let me check in terms of radians, not degrees. Not degrees. Please convert your calculator from degrees mode to radians mode 94255 25538 0.4794 255,386. This is sine of 0.5. If you take 0.5 in the first 3-4 terms only, it is not required to consider all terms of the series. You just take only first 3-4 terms of the sin x expansion and substitute x is equal to 0.5 in the first 3-4 terms only. Take x is equal to 0.5 here and simplify this and let me know. Tell me this value. Simplify this and tell me this value. Zero 0.4794 27083. Okay, fine. You are saying 0.4794 270,833. Listen to me, all of you. If I take x is equal to 0.5 here, then it is sine of 0.5. Whatever the answer you get for sine of 0.5, same answer you will get when you take x is equal to 0.5 in all these infinite number of terms of the right side. But we did not substitute x is equal to 0.5 in all these infinite number of terms of the right side of the series. I have just substituted x is equal to 0.5 in the first 3 terms only. I did not substitute x is equal to 0.5 from this term to infinity. From here to infinity, I did not substitute x is equal to 0.5. That's why little bit error will occur, because if I take x is equal to 0.5 here, then sine of 0.5, whatever the answer you get, you should get the same answer when you take x is equal to 0.5 in all these infinite number of terms of the series. But we did not substitute, we did not take infinite number of terms of the series. We just took only 3 terms of the series. From here to infinity, we are omitting the remaining terms. From x power 7 by 7 factorial to remaining terms, we are omitting from the series and substituting x is equal to 0.5 in the first 3 terms only. By omitting from here to infinity, it will contribute little bit error. That little bit error is called truncation error. So this is the exact value. Sine of 0.5, whatever the answer you get, that is the exact value. This is the approximate value. This is the approximate value. How can you say this is the approximate value? Because you have taken x is equal to 0.5 in the first 3 terms only. You did not substitute x is equal to 0.5 in each and every term of infinite number of terms. Only in the first 3 terms only we substituted. That's why that is not the exact value. That is approximate value only. Truncation error. Remember, error means exact value minus approximate value is called error. Truncation error is also here exact value. Truncation error is also exact value minus approximate value. But how this error has been generated? exact value sine of 0.5 minus approximate value 0.5 minus 0.5 whole cube by 3 factorial plus 0.5 whole power 5 by 5 factorial. How did you get this error value? Just how did you get approximate value? Just by omitting the terms. I have substituted x is equal to 0.5 in the first three terms only. And I did not substitute x is equal to 0.5 from this term to infinite number of terms. I have deleted some infinite number of terms of the series. So then we got approximate value. Little bit error has been generated just by deleting some terms of the infinite series. That generated error is called truncation error. How did you get truncation error? The error arises when this infinite series is truncated. Truncation error means the error occurs when this infinite series is truncated. When this infinite series is truncated by a polynomial. By a polynomial means finite number of the terms of the series. An error occurred by truncating infinite number of terms to finite number of terms. Truncate. Truncate means cut. Truncate means cut. Truncation means cut. So definition is, this is concept, man. We are not solving lengthy questions. Where did we solve lengthy questions? Check. Where did we solve lengthy questions here? Only one or two problems. This is concept. So definition, truncation error. The error arises when Nunavad Dasu, what is your doubt? Please unmute and ask me. Nunavad Dasu, what is the doubt? The error arises when an infinite series is truncated. Infinite series is cut by finite series. When infinite series is truncated by a polynomial. Nunav Dasu, please mute yourself. Nunav Dasu, mute yourself. Is called truncation error. The error occurs when an infinite series, this is infinite series. Infinite series is cut by only finite series. That finite series is called polynomial. That is called truncation error. Note, simply remember this before going to solve the problems. Error means exact value minus approximate value. Absolute error means modulus of exact value minus approximate value. Modulus of exact value minus approximate value. That is the definition of absolute error. What is the relative error? Relative error means what? Absolute error by exact value. Percentage error means what? Relative error must be multiplied by 100. Relative error is multiplied by 100. That is percentage error. And what do you mean by truncation error? Error occurs when an infinite series is truncated. Infinite series is truncated means cut. When an infinite series is truncated means cut by a polynomial. Polynomial means infinite series is cut by finite number of terms. That finite number of terms is a polynomial. That is truncation error. Write the problems. So there are several methods to find the solution of the first order differential equation. Among such methods, the first method to find the solution of the differential equation is Taylor series method. Naresh, any doubt regarding the subject? You might have raised the hand here. Solve by Taylor series expansion up to h squared terms. Remember, you are asked to solve one problem using Taylor series up to h squared terms. Taylor series up to h squared terms means Taylor series up to second derivative. Taylor series up to h cube terms means Taylor series up to third derivative. And evaluate y of 0.2 if dy by dx plus 2xy is equal to 4 with y of 0 is equal to 0.2. Now, let us find the solution of this differential equation using Taylor series formula. Now, the general form of the differential equation is dy by dx is equal to f of xy. So, dy by dx is equal to 4 minus 2xy. 2xy will go right, then it becomes 4 minus 2xy. Do you know the initial condition meaning? Initial condition in the general form. Remember, initial condition is y value at x naught is equal to y naught. Y value at x naught is y naught. So y value at x naught will be y naught. Now dy by dx is equal to, remember everyone, dy by dx is also written as y dash. Dy by dt can be written as y dash of t. Dy by dx should also be written as y dash of x. Minus 2x into y dash is written as y dash of x. Similarly, let us write y as y of x. Y dash is written as y dash of x. Write y as y of x. And observe everyone. We need first term of Taylor series is y of x naught. Y of x naught. Y of x naught is y naught. That was given. Second term of Taylor series is y dash of x naught. Observe y dash of x naught. So y dash of x naught. What is x naught? 0. Y dash of 0 is equal to y dash of 0 is x value 0. 2 into 0, 0. So this is only 4. Now next term y double dash of x naught. Y double dash of x naught means y double dash of x naught value 0. So first to find y double dash of x, 4 is constant, it's a derivative 0. This is u, this is v, uv rule. U, v derivative plus v, u derivative. Minus 2x into y of x derivative y dash of x. Next y of x as it is, minus 2x derivative minus 2. So find y double dash of x, y double dash of x naught. X naught means 0. If I take y double dash of 0, minus 2 into 0, 0, this term 0. This is minus 2 into y of 0. Y of 0 is already given in the statement of the problem. Here, y of 0 is 0.2. So this is minus 2 into 0.2, that is equal to minus 0.4. Remember, up to h squared terms means up to second derivative. Up to second derivative. I am writing the Taylor series. I am writing this Taylor series up to h squared terms up to second derivative. Write that. Y of x is equal to y of x naught. Our x naught is 0. Y of x naught means y of 0. X minus x naught value. X minus x naught 0. Y dash of x naught means y dash of 0 plus x minus x naught whole square by 2 factorial into y double dash of x naught. X naught means 0 up to second derivative. Y of x is equal to y of 0. Y of 0, 0.2. Here y dash of 0. Y dash of 0 is 4. 4x. X square by 2 factorial means 2. Y double dash of 0 here, sorry. Y double dash of 0 is minus 0.4. So y of x is equal to 0.2 plus 4x minus 0.2 into plus x square. This is the solution of the given differential equation. If anybody has a doubt, you can solve the given differential equation. You will get this answer only. But you are asked to find the solution of the given differential equation. At which point you are asked to find y of 0.2. What is y when x is equal to 0.2? Y of 0.2. Tell me the answer. What is the answer? And 0.992. Remember, engineering services examination, in the exam, problems will be given in such a way that we are able to solve it directly without using calculator. In such a way, the problems will be given in ESC. Generally, for engineering services examination, rarely this model will be covered. You will be given a problems that you are able to solve within the stipulated time, within 1 minute only. These types of problems won't be given in ESC. ESC problems I will show you. Next. These lengthy problems will not be given in ESC. Definitely you will be given the problems that you are able to solve within the given time only. Next problem. Let y be the solution of initial value problem dy by dx is equal to x plus y square using engineering services exam ESC numerical methods least priority for ESC. For GATE it is important. Using Taylor series method, because I'm teaching both for GATE and ESC, that's why. Using Taylor series method of order 2, with the step size h is equal to 0.1, the approximate value of y of 0.1 is 1.315, 1.415, remember Taylor series method of order 2. Taylor series method of order 2 means Taylor series up to second derivative. Taylor series method of order 3 means Taylor series up to third derivative. Write down. dy by dx is equal to x plus y square. Remember, the general form of initial condition is y value at x naught should be y naught. Y at x naught should be y naught. So dy by dx, dy by dx is y dash of x. Dy by dt is y dash of t. Remember, dy by dx is y dash, but I wrote it as y dash of x. If y dash is written as y dash of x, then y should be written as y of x. Y square should be written as y of x whole square. So we need y dash of x naught, x naught. What is x naught value? 0. Y dash of x naught means y dash of 0 is equal to 0 plus x value 0, 0 plus y of 0 whole square means 1 square. Y double dash of x, x derivative 1. Treat it as y. It is not, treat it as y, y square. Y square derivative 2y. Y means y of x. And again, y derivative with respect to x is y dash of x. And we need y double dash of x naught. X naught means 0. Y double dash of x naught. X naught means 0. So y double dash of x naught means 0. That is equal to 1 plus 2 into y of 0, y dash of 0. Y of 0 is given to be 1. Y dash of 0 is also given to be 1. So answer 3. Write down. The Taylor series up to second derivative is y of x is equal to y of x naught 0 plus x minus x naught into y dash of x naught means y dash of 0 plus x minus x naught whole square by 2 factorial into y double dash of x naught means 0. See, in the GATE examination, 65 questions are to be answered in 180 minutes. So the average time for each problem should be approximately more than 2.5 minutes. So we can easily solve these 2-3 steps in 2.5 minutes. In 2.5 minutes, roughly how many steps you can write? You can estimate. Y of 0, 1. Y dash of 0, 1. So x into y dash of 0 plus x square by 2 factorial into y double dash of 0. Y double dash of 0 is 3. 3 into x square by 2 factorial is 2. But we were asked to find y of 0.1. Y of 0.1, 1 plus 0.1 plus 3 by 2 into 0.1 whole square. Simplify this and tell me the answer. I think 1.115. Yes. Option C is the right answer. Just note this and try yourself. solve by Taylor series. Solve by Taylor series method. Of order 2 for dy by dx is equal to e to the power of x minus y square with y of 0 is equal to 1 the approximate value of y of 0.1. Try yourself. We will continue after the break. How you did not get y double dash? This is y dash. Y double dash means what? X derivative 1. Treat it as y. Y square derivative 2y. And again y derivative y dash. Y square derivative 2y and again y derivative y dash. So y double dash of 0 is equal to 1 plus 2 into y of 0 y dash of 0. 1 plus 2 into y of 0 given 1. Y dash of 0 here 1. We'll continue after the break. 15 minutes break. After the break, I will ask you the answer for this. Next model, there are several methods to find the solution of first order and first degree differential equations. Next model, Euler's method. Or first order Euler's method. Next model, model number 2. There are several methods to find the solution of first order differential equations. Second model, Euler's method, also called first order Euler's method, also called forward Euler's method, also called Euler's explicit method, also called Euler Cauchy method, or tangent method. Write down. Given dy by dx is equal to f of x comma y with initial condition y value at x naught is equal to y naught. So the procedure of finding the approximation values, I will let you know. Look, draw this diagram. The solution of any first order differential equation is represented by a curve. Solution of any first order differential equation is represented by curve. Let this curve be y is equal to f of x. As we discussed already, solution of the differential equation must be split up into equal lengths of subintervals. Equal lengths of subintervals. This is the solution of the differential equation. Curve equation is the solution of the differential equation. And tell me the points. This is x naught. This point is x is equal to x naught. If I take x is equal to x naught, y is equal to f of x naught. Y is equal to f of x naught. F of x naught also written as y naught. x1, y1, x2, y2, xn, yn. Now I want to draw a tangent to the curve. I want to draw a tangent to the curve at the point x0, y0. I have drawn a tangent to the curve at the point x0, y0. Write this. Draw a tangent to the curve at x0, y0. Means at this point. Do you know equation of the tangent formula? Equation of the tangent formula. Y minus y naught is equal to m into x minus x naught. This is the formula for equation of the tangent passing through the point x naught, y naught. So y minus y naught is equal to m. M means slope. Slope also denoted by dy by dx into x minus x naught. So y is equal to f of x. So dy by dx is equal to, look there, dy by dx is equal to f of xy. Dy by dx is equal to f of xy. This dy by dx is f of xy. We have drawn slope of the tangent is required at which point? At x0, y0. Dy by dx is the slope of the tangent that is drawn at the point x0, y0. So this is y minus y0 is equal to, substitute x is equal to x0, y is equal to y0. This is the equation of the tangent passing through the point x0, y0. Now I want to find y value at x is equal to x0. Remember, y value at x is equal to x0 should be y0. Y value at x0 should be y0. Y value at x1, y value at x1 should be y1. So at x is equal to x1, this y value will now be y1 minus y0 is equal to f of x0, y0. Here x is equal to x1. So x1 minus x0. As we discussed already, x1 minus x0 is the step size denoted by h. Y1 minus y0 is equal to h into f of x0, y0. Take this y0 to the right. Y0 plus h into f of x0, y0. What is this? This is the first approximation. Guess the second approximation. First approximation is y1. Second approximation is y2. y1 is equal to y0. So y2 is equal to y1 plus h into f of x1 comma y1. Next, third approximation, y3 is equal to y1 is equal to y0 plus y2 is equal to y1 plus y3 is equal to y2 plus h into f of x2 comma y2. Now I want to write n plus 1th approximation. Nth approximation is yn. N plus 1th approximation is yn plus 1 is equal to yn plus h into this is n plus 1th approximation. We have derived a formula. So remember the last one, which is the iteration formula, should be remembered, should be used to solve the problems. Before solving problems, note. Listen to me carefully, everyone. If you have a doubt, you solve one problem using Taylor series up to first derivative. If you have a doubt, you solve one problem using Taylor series. Mr. Ash Patel, in Taylor series also we have first and second approximations. Y of 0.1 is the first approximation, y of 0.2 is the second approximation, y of 0.3 is the third approximation. Based on the step size, we have to find. But generally, we were asked only first approximation. Remember, all of you, if you have a doubt, solve one problem using Taylor series up to first derivative. Solve the same problem using Euler's method formula and observe the difference between the answers. Both answers are almost same. That's why we can say that Euler's method agrees with the Taylor series up to first derivative. Means when you solve one problem using Euler's method and solve the same problem using Taylor series up to first derivative, almost same answers you get. So we can say that. But in the exam, instead of Euler's method, you should not use a Taylor series. Euler's method agrees with the Taylor series up to first derivative. Look here, in case you are trying to Euler's method formula, so when you solve one problem using Euler's method, whatever the answer you get, that answer is approximately equal to Taylor series up to first derivative answer. In case Euler's method problem, if you try to solve using Taylor series up to second derivative or up to third derivative or up to second derivative, it will give some error value because Euler's method equal to Taylor series up to first derivative only. That's why you may solve Euler's method problem using Taylor series formula up to first derivative only. In case Euler's method formula, Euler's method problem, if you can try to solve using Taylor series up to second derivative, that will contribute some errors. Second derivative is h square by 2 factorial into y double dash. This is the error term for Euler's method. So error order of Euler's method is 2 because Euler's method is a first order method, but its error order is 2. Why error order is 2? Because Euler's method doesn't equal to Taylor series up to second derivative. That's why error order is 2, but it is a first order method. Euler's method is a first order method, but its error order is 2. Listen to me, everyone. What I said here, I have drawn a tangent to the curve at this point. Similarly, you can draw the tangent to the curve at this point, at this point. Look here, everyone, in this interval, and observe this. This is the interval. I have drawn a tangent. This diagram I am saying. This diagram. This is the curve. This is the tangent. Curve is the exact solution. Curve is the exact solution. Tangent is the this curve you have already mentioned, that is the solution. Curve is the exact solution. Tangent is the approximate solution. And this is exact solution. Tangent is the approximate solution because the length of the curve is approximately equal to length of the tangent. That's why if curve is the exact solution, tangent should be the approximate solution. But if interval length is very, very, very small, shape of the curve and the shape of the tangent same. Interval length is very, very small. Interval length is very, very small. Observe this. Interval length is very, very small. Curve shape and tangent shape almost same. That means curve is exact solution, tangent is exact solution. Exact solution become approximate solution becomes exact solution if interval length is very small. Interval length is very, very small. Shape of the curve is equal to shape of the tangent. Means exact solution is approximately equal to tangent solution. Approximate solution. So we can write like this. Smaller step size is to be chosen for greater accuracy. Means if you want more and more accurate answer, you need to split the given interval into equal lengths of subintervals such that every subinterval length is very, very, very small, so that curve shape and tangent shape almost same. Next, Euler's method is stable if the step size satisfies the condition fourth condition meaning is, as we discussed already, to solve any problem, you need to split the given interval into equal lengths of subintervals such that every subinterval length is very, very, very small. What is the, among all these small subintervals, what is the maximum possible subinterval size one has to choose? Suppose you want to know what is the maximum possible subinterval size if you want to choose, in order to split the given interval into equal lengths of subintervals, then you need to apply this condition. By applying this condition, you will get range of h. By applying this condition, if you get 0 less than h less than 3, that means smallest subinterval size is 0, largest subinterval size is 3. That means you can split the given interval into equal lengths of subintervals such that the maximum subinterval size is 3. By using that formula, we will get the maximum possible subinterval size. Now we do problems. Euler's method is very, very important and expected for exam point of view. Problem number 1. Note down. Variation of water depth. Variation of water depth y in a gradually varied open channel flow is given by the first order differential equation given initial condition y value at x is equal to 0 is 0.8 meters. Full stop. The depth within the brackets in meters. Depth of the water in meters up to 3 decimal places of flow at a downstream section at x is equal to 1 meter from one calculation step of single step Euler's method is dash. Given in the GATE Civil Engineering 2018. Remember, you are given dy by dx. That is equal to 1 minus e power minus 10 by 3 ln y 250 minus 45 minus e power minus 3 ln y. Initial condition was also given to be y value at x is equal to 0 is 0.8 meters. Remember, this differential equation represents variation of water depth in a gradually varied open channel flow. And initial condition means y means water depth, x means distance. Water depth at x is equal to 0 meters is 0.8 meters. Now you are asked to find the depth of the water at a downstream section at x is equal to 1 meter. Y means water depth, x means distance. Water depth at x is equal to 0 meters is 0.8 meters. Now we were asked to find water depth at x is equal to 1. Listen to me everyone. To solve any problem regarding numerical method, first of all, regarding Euler's method, modified Euler's method and Rangi-Kutta methods, you need to split the given problem into equal lengths of subintervals. This is x0, this is x1, this is x2. What is x0? This is x0, this is x1, this is x2. What is x0? Initial condition is x0. This is y value at x0 should be y0. Y value at x0 should be y0. So x0 is 0. Subinterval's length. Length of the subinterval is not given, but we can find. Listen to me. You are given water depth at x is equal to 0. You are given water depth at x is equal to 0. You are asked to find water depth at x is equal to 1. So the gap between x is equal to 0 and x is equal to 1 is 1 unit. So subinterval size h is equal to 1. Water depth at x is equal to 0 is given. Water depth at x is equal to 1 is required. So this is x0, this is x1, this is x2. If subinterval length is 1 unit, this is 1. If subinterval length is 1 unit, this is 2. Do you know y value at x0 should be y0? Y value at x1 should be y1. Y value at x2 should be y2. Now you are asked to find water depth at x is equal to 1. Water depth at x is equal to 1 means y1. Directly we need to find y1 only. What is y1 formula? Look there, this is the first one. Y1 formula y0 plus h into f of x0 comma y0. Y1 means water depth Actually, we need water depth at x is equal to 1 meter. That is y1 is equal to y naught plus h into f of x naught comma y naught. So what is y naught? 0.8. Subinterval length 1. F of x naught. What is x naught? 0. What is y naught? 0.8. F of 0 comma 0.8. Do you know dy by dx also denoted by f of xy? Dy by dx is also denoted by f of xy. So this is f of xy. Now we need f of 0 comma 0.8. F of 0 comma 0.8. Substitute x value 0, y value 0.8. Here in this equation take x 0, y 0.8. That is 1 minus e power minus 10 by 3 into ln y by 250 minus 45 into e power minus 3 ln y. Simplify this and let me know the answer. What is the answer? Gate key 0.78 to 0.80. Any answer between these two will be the right answer. Any answer between these two. 0.793. Fine. In the exam, any number you write between these two, full marks will be given. Next problem number 2. An explicit forward Euler's method is used numerically is used to numerically integrate the differential equation dy by dx is equal to y using a time step of 0.1 with initial condition y of 0 is equal to 1. The value of y of 1 computed by this method is dash. Correct to 2 decimal places. Any answer between 2.55 and 2.65 is the right answer. It was also given in the gate gate mechanical engineering. Try later. Next. Problem number 3. The solution of the differential equation and dy by dx is equal to y minus x by y plus x. With initial condition y of 0 is equal to 0.2. Sorry, y of 0 is equal to 1. Yet x is equal to 0.1. With h is equal to 0.1. By Euler's method is dash. As we discussed already, first of all, the given differential equation is dy by dx is equal to y minus x by y plus x. Do you know the general form of the differential equation is dy by dx is equal to f of xy with initial condition y of x naught is equal to y naught. Please remember, initial condition y value at x naught should be y naught. And split the given interval into equal lengths of subintervals. This is x naught, this is x1, this is x2. X naught value 0, x naught value 0, subinterval length 0.1. If this interval length 0.1, then this value should be 0.1. If this subinterval length 0.1, this value should be 0.2 because 0.2 minus 0.1, 0.1, 0.1 minus 0, 0.1. Y value at x naught, y naught, y value at x1, y1, y value at x2, y2. Now, you should be careful. You are asked to find y value at 0.1. Remember, y value at 0.1. Y value at 0.1 should be y1 only. Only y1 is required. Y of 0.1 is equal to y1 plus y0 plus h into f of x0 comma y0. What is y0? 1. What is h value? 0.1. F of x0 0, y0 1. Substitute 1 plus 0.1 into f of 0 comma 1. F of 0 comma 1. X value 0, y value 1. X value 0, y value 1. So 1 minus 0 by 1 plus 0. That is 1.1. Problem number 3. Consider the equation du by dt is equal to 3t square plus 4 3t square plus 4 with u is equal to 0. So some students, they are asking, they did not understand h value. This problem h value okay. And first problem h value, listen to me. You are given water depth at x is equal to 0. Y means depth of the water, x means distance. Water depth at x is equal to 0 is given. And we are asked to find water depth at x is equal to 1. Water depth at x is equal to 0 is given, and we were asked to find water depth at x is equal to 1 meter. Therefore, the distance between x is equal to 0 and x is equal to 1 is 1 unit. So subinterval length, water depth at x is equal to 0 is given, and water depth at x is equal to 1 required. So the distance between these two is 1 unit. So h value 1. Write this. This is u is equal to 0 yet t is equal to 0. This is numerically solved. This is numerically solved by using forward Euler's method. With a step size delta t is equal to 2. The absolute error at the end of First time step is step size generally denoted by h, but in this problem they assumed it as delta t. No issue. Delta t means step size only. Start the solution. This problem given in the gate civil engineering 2017. Given du by dt is equal to 3t square plus 1. What is the general form actually? Dy by dx. General form is dy by dx. Dy by dx is equal to f of x comma y. X comma y. X means t, y means u. With initial condition y of x naught is equal to y naught. With initial condition y. Y means u. Y of x naught. X naught means x naught, y means u, x naught means t naught. T naught means 0. T naught means 0. This one. T naught means 0. Y of x naught is equal to y naught. Y naught means u naught. U naught means 0. This u naught means 0. So this is y value at x naught. X naught means t naught is equal to y naught. Y naught means u naught. Listen to me, everyone. You are asked to find absolute error. Absolute error means exact value minus approximate value. Absolute error means modulus of exact value minus approximate value. Approximate value means Euler's method solution. Any numerical method solution is a approximate value only. So you are asked to find the absolute error at the end of first step, first time step. Absolute error at the end of first time step means absolute error after the first approximation. First approximation is y1 is equal to, y1 means u1. y1 is equal to, y means u, y naught plus h into f of x naught. X naught means t naught comma y naught. Y naught means u naught. That is equal to u naught. U naught is 0 plus step size was given to be 2. H value 2. F of t naught 0 comma 0. 2 into f of 0 comma 0. 0 comma 0. 3 into 0 0. 0 plus 1. Any numerical method solution is a, this is the first approximation. Any numerical method solution is a approximate solution only. This is Euler's method, first approximation. So this is approximate value, not exact value. Remember, exact value means direct solving. Do you know how can you solve it directly? What is given? Du by dt is equal to 3t square plus 1. Exact solution means a direct solving of the given differential equation. Direct solving of the given differential equation will be like this. Du is equal to 3t square plus 1 into dt. Integral du is equal to integral 3t square plus 1 into dt. Integral du is u. Direct solving is exact solution. 3t square integration 3t cube by 3 t cube plus integral 1 into dt. Integral dt is t. Integration completed, add some constant. Integration completed, add some constant. You are given condition. What is the condition we were given? u0, t0. Here to t0, we have u0. Then equation number 1 implies that u0, t0 in equation number 1. So c0. So equation number 1 implies that u is equal to t cube plus t. But we were asked to find listen to me in this problem also step size. See here. This is initially this is 2. See here. Initially this is 2. Y of x naught is equal to y naught. Y of x naught is equal to y naught. X naught value 0. Y of x naught is equal to y naught. So x naught value 0. And this is t1. Actually, in the previous models, I have written x naught, x1, x2, x3, etc. Here x means t. T0, t1, t2, t3, etc. T0 value 0. Next to t1 value we don't know. X0 value 0, x1 value we don't know. But they said subinterval length is 2. If this interval length is 2, this is 0. If this interval length is 2, this should be 2. 2 minus 0, 2. So you are asked to find the absolute error at the first approximation. Absolute error at the first approximation means exact value after the first step. After the first step, what is u value? What is t value here? Here t value 2. Right. You are asked to find what is the absolute error after the first approximation. First approximation means u value at t1. First approximation means u value at t1. Second approximation means u value at t2. So u value at t1 is 2. So at t is equal to 2, u is equal to 2q plus 2, that is 10. Therefore, absolute error is equal to modulus of exact solution minus approximate solution, that is 8. Similarly, note this and try yourself. I think this is problem number 4. I don't know, Vishwateja, what you are asking. Which one we have to follow means what? See why you are getting confused. I did not understand. Look here, interval length must be split up into equal lengths of subintervals. Don't use the formula because number of subintervals not given. Don't use this formula to find end point minus initial point divided by number of subintervals. Number of subintervals they did not give. Don't use the formula. See here. Still you have a doubt here. Look, everyone, look here. Already I said x1 is equal to x0 plus h. I have already given this formula in the introduction. Verify. x1 means t1. T1 is equal to t0 plus h. What is t0? 0. 0 plus h. What is h value? 2. This is the way. Already to find x1, x2, x3 values, no need to remember anything. Directly I gave the formula no. See, in the introduction of this model, I gave already x1 is equal to x0 plus h, x1 is equal to x0 plus 2h, x means t here, t1 is equal to t0 plus h, t2 is equal to t0 plus 2h, x3 is equal to x0 plus 3h, so on. This is the way. By using this directly, we will get x0, x1, x2, x3, everything. No need to, by using h value, no need to remember anything. Note this and try yourself. Solve dy by dx is equal to minus y numerically from x is equal to 0 to x is equal to 1 using explicit forward first order Euler method with initial condition of y of 0 is equal to 1 and the step size of 0.2 the absolute value of error in y of 1 calculated using analytical analytical means exact solution, numerical solution means approximate solution. Using analytical and numerical solution is dash. We need to write the answer in terms of percentage. Analytical solution means exact solution, numerical solution means approximate solution. Calculate the error using the analytical solution as the basis and use 3 decimal places. 100% similar to the previous problem model. Try yourself. Answer range 10.15 to 11.5. Answer range 10.5 to 10.5 to 11.5. Any number between these two will be the right answer only. Next. Modified Euler's method. It is also called improved Euler-Cauchy method. Also called Haynes method. Write down. Given we have different methods to find the solution of the first order differential equation. One is Taylor series method, previous one is Euler's method, this is modified Euler's method. Given dy by dx is equal to f of x comma y with initial condition y of x naught is equal to y naught. See, the derivation of modified Euler's method is also a little bit similar to previous model only. That's why directly I give you the formula. Directly I give you the formula. Derivation almost similar to the previous model only. The first approximation is y1 power p is equal to y naught plus modified Euler's method means whatever the solution we get in Euler's method, that should again be modified with the help of modified Euler's method. What is P? P means predictor. P means predictor, means guessing. Predictor formula. So we are just predicting the modified Euler's method. We are just predicting the first approximation. So that is prediction only, not final value. Y1 power C. C means correction. Correction means already predicted formula should be corrected again to get more and more accurate answer. This is y1 power p plus h by 2 into y1 power p into h by 2 into f of x naught comma y naught plus f of x1 comma y1 power p. Y1 power C. C means corrector. Next. Y1 power C1. y1 power c1 means this is corrector formula. C1 means correcting one more time. Correcting one more time. 1 minute. 1 minute, students. A small modification. This is y0 only. This is y0 only. Next. This is y0 plus h by 2 into f of x0 comma y0 next y1 power c2 is equal to y0 plus h by 2 into f of x0 comma y0 f of x1 comma y1 power c1 so on. Till accuracy, we have to find y1 power c, y1 power c1, y1 power c2 so on. When do we stop the iteration? The difference between one value and its previous value should be less than or equal to epsilon. Epsilon means any number very, very nearer to 0 but not 0. Next. Everyone should remember Euler's method is also called Runge-Kuttas first order method. Euler's method is also called Runge-Kuttas first order method. Now Runge-Kuttas second order method. Write down. The purpose of all these methods is to find the solution of the first order differential equation only. Using any numerical methods, we will get the nearest possible solution only. Any numerical solution is a approximate solution, not exact solution. I am giving formula directly, derivation similar to Euler's method only. A small modification for that Euler's method to get the derivation of this. The first approximation is y1 is equal to y0 plus k. Where k is equal to k1 plus k2. K1 is equal to h into f of x0 comma y0. K2 is equal to h into f of x0 plus h comma y0 plus k1. Listen to me, everyone. You solve one problem using a Taylor series up to second derivative. Solve the same problem using Runge-Kuttas second order method. Both are almost give you the same answer only. So we can claim that, we can conclude that Runge-Kuttas second order method agrees with the Taylor series up to second derivative. Means Rangi-Kutta method problems can also be solved using Taylor series up to second derivative, but we should not solve in the exam. Almost the same answer, not 100% same answer. So any Rangi-Kutta methods problem, if you can solve using Taylor series up to third derivative or higher than third order derivative, that doesn't give you accurate answer. That will give you some errors. Therefore, Rangi-Kutta second order method equal to Taylor series up to second derivative only. I don't. RK second order method agrees with agrees means equal to Taylor series up to second derivative. In case Rangi-Kutta second order method problem, if you try to solve using Taylor series up to third derivative, definitely it will contribute errors. Definitely it contributes errors. So that's why error term starts from third derivative of Taylor series for RK second order method. Error order is 3. Because it is equal to Taylor series up to second derivative only. If you can solve up to third derivative, you will get error values. That's why error order is 3. As we discussed already in the previous model, we need to take small step size. Small step size is to be chosen for good accuracy, for greater accuracy. Similarly, as we discussed in the previous model, this is also RK second order method is stable if the step size h satisfies remember generally we need to split the given problem into equal lengths of subintervals. What is the maximum possible subinterval size we need to choose in order to split the given interval into equal lengths of subintervals? For the stability of Rangi-Kutta second order method, you need to apply this formula. Stable of Rangi-Kutta second order method means it is reliable for correct answers, reliable for accurate answers. Once again, listen to me, everyone. Rangi-Kutta second order method agrees with the Taylor series up to second derivative. That's why in the examination, instead of Rangi-Kutta second order method, you should not use Taylor series up to second derivative. Moreover, one more thing you people have to remember. If you see, all modified Euler's method problems can also be solved second order RK method and vice versa. In the examination, suppose you are asked to solve one problem using second order RK method, you can solve that problem using modified Euler's method or vice versa. That means if you are asked to solve one problem using modified Euler's method, you can still solve that problem using second order RK method, because modified Euler's method formula Modified Euler's method formulas, if you can simplify this, it will be converted to second order RK method only. That's why all modified Euler's method problems in the examination can also be solved using second order RK method and vice versa. Rangi-Kutta's third order method is not in the syllabus. Rangi-Kutta's third order method not in the syllabus. Now we have Rangi-Kutta's fourth order method. I am giving formula only, derivation, similar type of diagram of Euler's method only, but little bit difference, change. That's why directly I am giving the formulas. Given dy by dx is equal to f of x comma y with initial condition y value at x naught is equal to y naught. The first approximation is y1 is equal to y naught plus k. Where k is equal to 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. K2 is equal to h into f of x naught plus h by 2 comma y naught plus k1 by 2. Next, k3 is equal to h into f of x naught plus h by 2 y naught plus k2 by 2. K4 is equal to h into f of x naught plus h comma y naught plus k3. Remember, Rangi-Kutta's second order method. See, Euler's method is equal to Taylor series up to first derivative. Euler's method is also called Rangi-Kutta's first order method. Rangi-Kutta's second order method is equal to Taylor series up to second derivative. Rangi-Kutta's third order method is equal to Taylor series up to third derivative. Rangi-Kutta's fourth order method is equal to Taylor series up to fourth derivative. In case Rangi-Kutta's fourth order method, if you try to solve using Taylor series up to fifth derivative, that doesn't give accurate value. So error should be 5. Error order should be 5. RK's fourth order method agrees with the Taylor series up to fourth derivative. In case RK's fourth order method problem, if you try to solve using Taylor series up to fifth derivative, definitely you will get error. You will not get accurate answer. So error order is 5. Already we discussed, always interval length should be small. Smaller step size is to be chosen for greater accuracy. To get more accurate answer, you need to take small step size. Next, Rangi-Kutta's fourth order method. Is stable. Stable means reliable for correct answers. If the step size h satisfies minus 2.78 less than h into dou f by dou y less than 0. By simplifying this, you will get range of h value range you get. Within that, you can split the given interval into equal lengths of subintervals. So then you will get maximum possible subinterval size. Just 5 minutes, one problem I'll teach and I'll stop. 5 minutes. Using Rangi's formula. Rangi-Kutta's second order method is simply called Rangi's method also. Using Rangi's formula of order 2, when x is equal to 1.1, given dy by dx is equal to 3x plus y square and y is equal to 1.2 when x is equal to 1, taking h is equal to 0.1, the value of y will be nearly option A, option B, option C, option D. Dy by dx is also denoted by f of xy is equal to 3x plus y square. Initial condition was given. Initial condition is y value 1.2 when x is equal to 1. Y value 1.2 when x is equal to 1. Y value 1.2 when x is equal to 1. This is the initial condition. Y value at x naught should be y naught. See, I said already, you need to split the given interval into equal lengths of subintervals. This is x naught, this is x1, x2. Subinterval size h is equal to 0.1. Subinterval size h is equal to 0.1. X naught value 1. Look there, x naught value 1. Every subinterval length, this subinterval length 0.1. Then what is x1 value? This is 1. If this interval length is 1.1, if this interval length is 0.1, it should be 1.1. 1.1 minus 1, 0.1. If this subinterval length is 0.1, what is this value? 1.2. 1.2 minus 1.1, 0.1. That is the way. H value 0.1 given already. So as you all know that y value at x naught is y naught. Y value at x naught is y naught. Y naught is already given 1.2. Similarly, y value at x1 should be y1. Y value at x2 should be y2. Suppose you don't know x1 value, you can use the formula. X1 is equal to x naught plus h. X2 is equal to x naught plus 2h. So y1, what is y1? And you are asked, remember, using Runge-Kutta second order method, you are asked to find the y value at 1.1. Y value at 1.1. Here, when x is equal to 1.1, what is the solution? At x is equal to 1.1, the corresponding y value should be y1. So we need to find y1. Y1 is equal to y naught plus k. K is equal to half into k1 plus k2. That's why we need to find k1 first. K1 is equal to h into f of x naught comma y naught. F of x naught comma y naught. 1 comma 1.2. F of 1 comma 1.2. F of 1 comma 1.2. X value 1, y value 1.2. Simplify this and let me know the answer. What is the value? 0.793 na? K1 0.444. K1 0.444. H value 0.1. F of x naught plus h. 1 plus 0.1, 1.1. Y naught plus K1. Y naught value 1.2. 0.444. 1.644. So 0.1 into f of x comma y, 3x plus y square. 3 into x plus y square. Simplify this and let me know the value of K2. K2 0.6003. Good. K2 0.6003. K is equal to 1 by 2 into K1 plus K2. What is K value? What is K value? This problem given engineering services examination prelims paper 2020. ESC prelims paper 2020 it was given. What is K value? Half into K1 plus K2. 0.5221. What is K1? 0.551. 0.551. Therefore, y1 is equal to y0 plus k. Y1 is equal to y0 plus k. What is y0? 1.2 plus 0.551. What is the value? The value should be nearly 1.200, 0.551, 157, 1.751. Option B. Because they said the value should be nearly. Okay, we'll stop. Students have doubts, you can ask me now. Any doubts, you can raise your hands. Anish Valmiki, you can unmute and ask me.
Sir, go to page number 35.
Page number 35.
Sir, in that question, the constant given was 4, but you took 1.
1 minute.
Question number 4.
Page number 35.
Yeah.
Nah.
So in this question only 30.
Where 4 is given? Tell me.
3t square plus 4.
No, not that constant. See, don't compare that. This is the solution.
No, sir, not constant. The above 3t square plus 1 you have taken.
3t square plus 4 it is. Oh, sorry. That's fine. Okay. 1 minute. Correct. 3t square. Sorry. 3t square plus 4. Let me check. F of 0, 0. 2 into f of 0, 0, 4.
Yes.
0 plus 4, right?
Yes, 6.
8, no?
8.
Sorry, this is a mistake. And here we check u is equal to t cube plus t. And at t is equal to 2, that is 2 cube plus 2, 10. What is the previous answer? What is the final answer I said? 8. Sorry, here at t is equal to what is the condition we were given? Yes, this is okay. U is equal to 0. U is equal to 0. Now, this is the condition. No, at which point we need to calculate? Tell me. here exact value. We are finding exact solution. Du by dt is equal to 0, u is equal to. Therefore, you are asked to find the absolute error at the end of first time step. First time step. What is the first time step? Here, if I take t is equal to 0, u is equal to, what is the answer I said? 8.
Yes.
This is 8. 3t square. Sorry, it's my mistake only. 1 minute. 1 minute. This is actually what I gave is correct. This is 3t square plus 1. Please change and modify yourself. Question itself is wrong. I have dictated. It is actually 3t square plus 1. It is actually 3t square plus 1. And this is actually 2. It's by mistake I said 4. It is 2 only actually. Now, at t is equal to 2, u is equal to 2q plus 2. 10. Question itself I have dictated wrong. It is 3d square plus 1 only.
Okay, sir. Sir, in Ranjikutta second order method, what will be the k value?
I gave no already. Ranjikutta second order method. K is equal to, sorry, K is equal to half into K1 plus K2.
Yes, only that in numerical you took a half.
Good. I forgot to say, in the problem.
In problem, that is correct.
In problem, that is okay, no?
Yes.
Okay, fine.
Thank you, sir.
And answer, some people have said the answer for K1 plus K2 or half into K1 plus K2, this answer.
Same, half into.
Fine. Good.
Thank you, sir.
Fine. Any other students? Any other student? Okay, I'll be going to end the session. Manjunath, please unmute yourself. Manjunath, unmute yourself and then tell me.
Hello.
Tell me why it's not clear.
Hello, sir.
Now okay.
No, sir. Sir, the answer K is 0.522. No, sir. 5.55.
I don't know the answer. What you people said, I have written the answer directly. 0. How much K value?
522, sir.
Let me check.
0.44 plus.
1 minute. What is K1?
0.444, sir. That is, both are correct, sir. K1, K2, sir.
0.444 plus
0.6.
0.6003 divided by 2. Correct. Why some students said wrong answer, I don't know. Tell me
0.522, sir.
522 up to 3 decimal places.
0.522.
522 and final answer 1.722.
722.
Good. That's it. Any other?
Okay, so okay, sir. Only, sir. That is.
Some students have written that. That's why I copied that.
No.
Fine. Any other students have any doubts? I'll be going to end the session. Session is going to be ended. Okay. Sai Charan, unmute. Sai Charan, unmute.
Sir, it's a general question. So for ASC overall, like, what are the topics which are somewhat priority from the maths?
From in numerical methods or general?
General maths, sir, because this is the only session we got live session. Remaining all we have pre-recorded sessions.
Okay. Generally, in matrices, eigenvalues we can expect for a ESC system of equations. ESC we cannot say this is important, this is unimportant. They will touch everything. In GATE we can say, because ESC there is no limit for that. They can expect anything. No expected questions in ESC in general, but in GATE we can expect, because ESC content is vast, but problem set moderate level only.
Okay, sir.
We cannot predict for ESE. Gate, okay. We can.
Okay, sir. Yeah, no. Yeah, thank you, sir.
Anish Valmiki. Anish Valmiki, do you have any?
Yes, sir. Sir, can you tell us about GATE? Which all topics would be expected in GATE?
Topic wise, you tell me. Which subject? Linear algebra or matrices, something like that.
So linear algebra.
Linear algebra, listen, linear algebra, the highest weightage are eigenvalues, eigenvectors. And the system of equations, eigenvalues, eigenvectors, 90% we can expect.
Okay, and in sir probability?
Probability, up to probability, everything is important. We cannot predict. Probability, binomial, Poisson, normal, okay. And basics, probability, we cannot expect anything. All are, except everything is important.
Okay, sir. In calculus?
Calculus, limits, 1 mark question will be given. Limits.
Okay.
After that, limits continuity, maximum limits, 1 mark problem will be given. Next to maxima, minima, and multiple integrals. Sorry, definite integrals, maxima, minima, multiple integrals.
Okay, sir.
And in vector calculus, line integral, Green's theorem, directional derivative, Green's theorem, directional derivative, line integral, Green's theorem, Gauss divergence theorem. Stokes.
Okay, sir. Sir, and this numerical method?
Numerical method, so this Newton-Raphson method.
Okay.
Next to Euler's method.
Okay.
Next to trapezoidal and Simpson's rule.
Okay, sir. So this is for civil?
This is for mechanical.
Okay, and for civil?
Your branch?
Civil, sir.
For civil, the day after tomorrow also you'll be having a class. That is also important. For civil also, Newton-Raphson method, Euler's method, modified Euler's method, and these trapezoidal Simpson's rule, plus some extra topics are there. Newton interpolation polynomial, Lagrange's interpolation polynomial, which are also important for civil.
Okay, sir. Thank you, sir.
Any other?
No, sir.
Sai Nikita, please unmute yourself.
Sir, can you once explain Euler's method second problem, sir?
Page number, did you remember?
No, sir.
This one, huh? One.
No, sir, before one. The next one. After this.
This one, huh?
No, sir, after this.
After this one, huh? du by dt is equal to 3t square plus 1.
No, sir, it is an explicit forward Euler's method is used.
This one, huh?
Second question.
This problem I gave for this one, huh?
Oh, yes, sir.
This one you need to find how many iterations you need to find, 1 minute. Look there, what you are given, tell me. Dy by dx is equal to problem. Hello? Dy by dx is equal to y. And what is the initial condition? Y of 0 is equal to 1.
Yes.
Y of 0 is equal to 1. And you are asked, see, this is x0, x1, x2, x3, so on. You have to split like this. What is x0 value? Tell me.
0 and
Zero.
y naught is 1.
Step size how much?
0.1.
0. If step size 0.1, 0.2, 0.3, 0.4, you are asked to find y of 1, no?
Okay, sir. Now I got.
This is y0, y1, y2. Then you need to find y10. You understand?
Yes,
Shall-
sir. Now I got it.
Is it clear?
Yes, sir. Yes, sir. Thank you, sir.
Oh. Any other student? Students, I'll be going to end the session. Okay, fine. Anil, unmute. Anil. Okay.